This is another very easy 4 marker. You're finding the coefficient of x squared in this binomial expansion of this linear term multiplying by a fractional power of 4 minus x. So this is an infinite expansion. So if you remember the formula which is given in MF19 as well, that is, if n is a fractional power, then this becomes 1 plus nx plus n times n minus 1 x squared over 2 factorial plus n times n minus 1 n minus 2 x cubed over 3 factorial plus dot c dots. Now, in order to have this 4 minus x converted into 1 plus x, we need to do something with this 4, right? So let me just quickly erase it and put it here. So this 4 minus x square root may be rewritten as 4 times 1 minus 1 upon 4x, the whole thing raised to the power half. Now, since the powers are shared between the two terms 4 and 1 minus 4 upon x, we can distribute the powers by the indices rule. So this becomes 4 times 4 to the power half, which is just 2 times 1 minus 1 upon 4x raised to the power half, which is nothing but 2 times 1 minus 1 upon 4x half. Okay. Now, just applying this formula here, we get, I'm just expanding this. So this becomes 2 times 1 plus n, which is half, x, which is minus 1 upon 4x, right? And plus n minus 1 over 2 factorial, which is 2, and x squared, which is minus 1 upon 4x whole square. And now, since we are just concerned with the power up till this power of x squared, we need not go ahead, right? Now, simplifying this, we get 2 times 1 minus 1 upon 8x. This becomes 16, 16 times 4, 64, 64. Oh, so minus 120, minus 1 upon 128 x squared plus dot dot dot. Now we can multiply this 2 inside, so this becomes 2 minus 1 upon 4x minus 1 upon 64 x squared plus dot dot dot. Now, we need to multiply this with 2x minus 5. So 2x minus 5, because we are looking for an x squared term, right? The coefficient of x squared. So this is 2 minus 1 upon 4x minus 1 upon 64 x squared plus infinitely many terms which we are not concerned with. Now, in order to get x squared, we will multiply this with this. So this becomes minus 1 upon 2x squared, and also multiply the constant term with the coefficient of x squared power to get 5 upon 64 x squared. Now, the coefficient then becomes minus 32 plus 5 over 20 over 64 x squared, which is simply minus 27 upon 64, right? So this is the coefficient of x squared, and this is your easy 4 marks, right? Now, the second part says that state the set of values of x for which the expansion in part A is valid. So the expansion in part A, we found out that this term of square root of 4 minus x was actually 1 minus 1 upon 4x raised to the power half. Now, for binomial expansion to converge, this term must become, so this term, if I can denote this by u, so u, modulus of u has to be less than 1, right? So if it is less than 1, then when we add it to a 1 and raise it to the power half or any fractional power, the series is going to converge. The summation is going to converge of the expansion, right? So this is simply minus 1 upon 4 x inside the modulus is less than 1, and you know the modulus function. So this minus 1 comes under modulus, and 1 upon 4 x comes under modulus. This modulus of negative 1 is simply 1, and this becomes 1 upon 4 x modulus is less than 1. And because now we have all positive terms, we can multiply both the sides by 4. So we get modulus of x has to be less than 4 for this series to be valid, or this expansion to be valid. This is another 1 mark, which is very easy. I'll see you in the next video.